This is part one of a lesson on quadratic functions. Quadratic functions are functions that have degree 2. See the x squared? See the squared right here? That's what makes it quadratic. And quadratic functions are always parabolas, which we will graph much better than that in a moment. And in fact, in this particular video, we will focus on graphing quadratic functions. Well, graphing quadratic functions is easy when you have a TI-30 XS multiview. You just go to your table function and type it in. Alright, so we have negative 2x squared plus 8x. Negative 2x squared plus 8x. Is that it? Okay, you hit enter a couple of times and we get a table of values. Now, here's what I want you to do though before we get too far gone. The vertex, let's figure out what this middle value should be. We're going to want the vertex to be in the middle of our graph. Okay, we want the vertex to be right here. The vertex is, if you have a parabola that's upside down, the vertex is at the top. If you have an upward facing parabola, the vertex is at the bottom. Anyway, if you want to know where the vertex is, you can use the following formula. The x value of the vertex is equal to opposite of b over 2a. This is a, negative 2, and this is b. C is 0, by the way. Anyway, so opposite of b over 2a. So b is 8. So opposite of b is negative 8 over 2 times negative 2. Now that makes negative 8 over negative 4, which makes positive 2. Alright, so what that is the x coordinate of the vertex. So that should go right here in the middle. So that means the rest of the x values will be decreasing from here. So this will be 1 and 0 and 3 and 4. To get the y values that go with these x values, that's what the calculator is for. So for 0, 1, and 2, we have 0, 6, and 8. And then, as we scroll down, we have 6 and 0. Alright, notice how after the vertex, these two values repeat. And these two values repeat. If that doesn't happen, you probably did something wrong, right? Because of the nature of a parabola, it is symmetric around the vertex, so the y values should be the same as you go away from the vertex. So now all we need to do is plot these points and draw the parabola. So we have 0, 0 is 1, and then 1, 6, 2, 8, and then it starts to repeat. So 3, 6, and 4, 0. Now, if you can fit more points on your graph, you should. So what I mean is go back to the calculator. If I kept going, the next point is 5, negative 10. So that would still fit on the graph, so let's graph it. And you know that means that negative 1, negative 10 would also be a point. Alright, so always plot as many points as will fit, not just the 5 points on the table that's right here. So now we'll just draw the parabola through these guide points. Alright, so your graph should look something like that. Alright, let's answer these questions that go along with the graph. What's the vertex? Well, here it is right in the middle. Our 2, 8 is the vertex. Is this a maximum or a minimum? Well, you see how it's at the very top of the mountain, so that makes this a maximum. Does the parabola turn up or down? See how the arms of the parabola are reaching toward the floor? Okay, if I put arrows on here, they would be pointing down. So this is a downward facing parabola. Axis of symmetry. The axis of symmetry is the invisible line that splits the parabola in half. It always passes through the vertex. So it's going to involve the number 2. Now vertical lines are always x equals something. So the axis of symmetry is the vertical line x equals 2. The zeros, very similar to the x-intercepts. Alright? If I asked you for the x-intercepts, you would say 0, 0, and you would say 4, 0. Those are the x-intercepts. Now, the zeros of a function are just the x values of that. So the zeros are 0 and 4. So closely related to the x-intercepts, except just the x values. Now, the y-intercept, on the other hand, is an ordered pair. And the y-intercept is wherever the function touches the y-axis, which in this case is 0, 0. The domain is the x values. For quadratic functions, the domain will always be negative infinity to positive infinity because of the way the x values go to the left forever and to the right forever. So that's negative infinity to positive infinity. Now the range is the y values. You have to give the range from bottom to top. It's always least to greatest. Now down here at the bottom, the graph continues on to negative infinity. At the top, it reaches a height of 8. So negative infinity to 8 is going to be the range. And we'll put a bracket on the 8 to show that 8 is included. If the parabola touches 8, it reaches 8. Okay, so that's it for problem number 1. This form of the equation is called standard form. When you just you have no parentheses and it's just ax squared plus bx plus c. That's standard form. On the other hand, problem number 2 is in vertex form. Alright, that's a form that looks like this, where you have y equals x minus h squared plus k. And in this case, the h and the k represent the vertex. In other words, the vertex you can read just by looking at this. It'll be the opposite of the inside, comma, the outside stays the same. So we have a positive 5, so that we'll have a negative 5, comma, and then negative 1 just stays negative 1. That'll be my vertex. So again, we can use our TI-30 XS multiview. Go to your table function, clear that out. So we have x plus 5 squared minus 1. Okay. Now, but first, going backwards, this should be negative 6, negative 7, and negative 4, and negative 3. So let's start at negative 7. So, negative 7, we have 3, 0, negative 1. Now, by symmetry, this should be 0 and 3. But let's just double check. 0 and 3. Great. So let's graph these points. So negative 7, 3 will be right here. Negative 6, 0. Negative 5, negative 1. Negative 4, 0. Negative 3, positive 3. So those are these 5 points. Let's see if any more points will fit. So if I go one step further, I have negative 2, 8. So negative 2, 8 will fit, which means this is also a point. So always graph as many points as will fit, and draw the parabola. So number 2 should look like that. Alright, now let's answer the questions that sort of go with it. The vertex. The vertex is this negative 5, negative 1. Okay. Is the vertex a maximum or a minimum? Well, you see how it's at the very bottom. That makes it a minimum. Is the parabola facing up or down? See how the arms are reaching toward the sky? That's up. Axis of symmetry. The axis of symmetry is the invisible line that splits the parabola in half. Okay, that's this vertical line here at negative 5. It's always going to involve the x value of the vertex. Vertical lines are x equals, so x equals negative 5. The zeros, that's another word for the x-intercepts, except we just look at the numbers, not the ordered pairs. So the zeros are these, negative 6 and negative 4. Okay, if it said x-intercepts, I would have written negative 6 comma 0 and negative 4 comma 0. But when it's zeros, you just use the numbers, not the ordered pair. But this says y-intercept, so I will use the ordered pair. Now the y-intercept is where the graph, any graph, touches the y-axis. Now that's not visible with the points that we've graphed so far, but that doesn't mean it does not exist. And in fact, it definitely exists, because this graph will drift to the right forever. It will eventually hit the y-axis, even if it's up here way off the graph. So how do we find it if it's off the graph? Well, we know the x-coordinate of the y-intercept. The y-intercept is always going to be on the y-axis, which means it'll be 0 comma something. So we know the y-intercept is 0 comma something. We just need to know the y value. Well, look back at your calculator. Just go to 0, and then that'll be your y-intercept. Alright, no wonder we couldn't see it. It's very big. In fact, I need my parentheses to be larger. Okay, the domain. The domain is the x values. This graph goes to the left forever and to the right forever. So that'll be negative infinity to positive infinity. The range is the y values. It will always be given from bottom to top. Alright, the lowest value is here at negative 1. Alright, so it will be negative 1. We'll use a square bracket to show that negative 1 is included in the range. The parabola touches negative 1. And then the parabola goes up forever, so positive infinity after that. So negative 1 to infinity, in that order. Okay, so that is it for number 2.